So this is College Algebra 5.6a, and we're continuing with exponential and logarithmic functions, and this section is called annuities and loan repayment. And for the most part, like 5.4 and 5.5, this is just taking formulas that they give you and plugging values in and getting the answer. So I suppose the one of the primary struggles is knowing what in the world they're asking you to do and what do all these new words and formulas actually mean. Actually figuring these out using the formulas is not that big a deal. It's just understanding what they're wanting you to do. Okay, so first thing to talk about is annuities. All right, so annuities is a financial plan characterized by regular payments. So let's say that you borrowed money and you are making regular payments made to an account to pay off a car or a house. That plan is an annuity. If you are starting the savings plan, let's say for retirement, and you are having $50 a week taken out of your paycheck regularly and put into an account for you, that's an annuity. Okay, so that's all we're looking at in this one. We're looking at just some things that you can get, things that you can figure out using the idea of an annuity. So, for example, here we have a formula where R is the money that you're putting in your account, I is your interest, N is the number of times that you're putting it into that, or the periods into an annuity that pays interest. Okay, so for N periods, which is going to be a certain number, and that will give you S. And S basically stands for your future value. Okay, so if you put in a certain amount of money, let's say that we put in $1,000. Okay, we're not going to do all the math. I'm just going to explain what's going on here. So we put $1,000 in for 5 years, and it's going to be 10% compounded per year annually. And maybe I want to know how much money I'm going to have at the end of 5 years. So I'm going to, put in numbers. 1,000 for my R, 1 plus the interest rate, in this case it's 10%, and that is going to be for 5 years. And I'm going to put that over my interest rate because the I shows up twice. And multiply all that out. So actually what I'm going to do is I'm going to take the 1 plus 0.1 and get 1.1 to the 5th power, subtract 1, divide it by that. Okay, so that's probably the most challenging part. Multiply that by 1,000 and I'm good to go. Okay, so that formula that we just used right here is for an ordinary annuity. Okay. As we continue on, they're going to give us another example using that same formula in example 1. So let me go ahead and write that formula down again so that we can refer back to it. Okay, and your unit of measure, or your unit, is dollars. So S is your future value. So example 1 says find the 5-year future value, find S, of an ordinary annuity with a contribution of $500 per quarter, so 4 times a year, into an account that pays 8% per year, compounded quarterly. Again, quarterly, 4 times a year. So it's very important. Okay, so let's first of all look at our N. Okay, our N is basically the number of times it's compounded during the time period. So we've got 5 years. It's compounded quarterly. So 4 times a year. So 4 times 5 is 20. So that's how many times it's going to be compounded over a period of 5 years. All right, let's also look at our interest rate. Our interest rate is per period. Okay, so how many times per year are we looking at the interest rate? Well, compounded quarterly. Okay, so we're doing it 4 times. So the period is quarterly 4 times at 8%, so it's 0.08 divided by 4. Okay, if that was annually, it'd be over 1. If it was semi-annually, it would be over 2. And that gives us 0.02 when we do the division there. Okay, so now that we have that information, let's go ahead and write the equation here. And our R is going to be $500. We don't care how often it does it. I mean, this is $500 per quarter, so $2,000 per year, but that doesn't matter. The year stuff shows up with all of this here. Okay, 1 plus 0.02, and that's 20, minus 1 over 0.02. So one of the key things is if you find out what your N is and your I, then you just rewrite it. You don't even have to look and do anything weird. You've already got the information here. You write it out, and you find out that in 5 years, that $500 every 3 months or quarterly is going to be worth that much at the end of 5 years. Okay, so actually, if you're going to do it for 5 years, you're ending up investing about $10,000 of your own money, but you're going to end up with $12,148.68. Okay, so bottom of 388, top of 389 shows you how to use your calculator to quickly and easily figure this out. But so you can try those if you want. I like to do them by hand. I like to teach them by hand so you understand what's going on here. And let's jump to example 2. And again, we're using a little bit different formula here. It appears, but it really isn't. Okay, sometimes the books just like to kind of throw you. All right, so let's put our original formula up here. And the formula that they give you, they start plugging stuff in. So let's first of all find out what our R is. Our R is $200. Our interest, let's see, deposit end of each month into an account that pays 12% interest per year compounded monthly. So that means the interest is 12% compounded monthly, or 12 times a year, which gives me 0.01. Okay, so remember, your interest is the interest divided by how often it's compounded, in this case monthly. Okay, so find the future value for every 4-month period. Okay, so that means this N right here is going to be 4, 8, 12, 16, 20, all the way up through 36. All right, you can use a calculator to figure this out, or you can do it by hand. But if you're gonna use this formula here, you're gonna have to do it 9 times in order to get up to 36 months, because it says for each or every 4 month. Okay, so what it's saying is, how much do you have every 4 months? So at the end of every 4 months, you can figure out how much money you have. So if you look at table 5.21, it will say at the end of 4 months, you're going to have $812.08. Okay? Some of that is going to be money that you put in because Harry deposited it at the end of each month. So $200 every month. At the end of 4 months, he's put in $800 and he's made $12.08. Okay, so not a whole lot, but as it's compounded, that number gets big quite quickly. Okay, so anyway, if you put in numbers for here of what we have S equals his 200 times, and what they did here in the example, they already added 1 plus 0.01 and got 1.01, and so they did, and then they subtract 1 from it over the interest. Okay, and this is an n, and that will be a 4, an 8, a 12, a 16 every 4 months. Okay, so you can do that with your calculator, or you can do that with your Excel spreadsheet, or do it by hand. But one of the key things they say in the solution area is this model for the future value of an ordinary annuity is a continuous function with discrete interpretation. Okay, so it's a continuous function, meaning that my line is continuous. There's no breaks in it, but we can only look at this at 4 months, at 8 months, at 12 months. You can't look and see how much you have somewhere in the middle. So discrete basically means you're only able to look at it at certain times or certain places on the graph. Okay, present value of an annuity. Now this is a very helpful part of doing annuities, in that, let's say that you are in your 40s and you came up with this vast sum of money that you want to put away and save it for retirement, and you want to know, okay, how much do I have to put in so that when I retire I can get, say, $2,000 a month for the next 20 years. Okay, so it kind of gives you an idea of how much money you're going to need before retirement, so that you can get a certain amount of money every month during your retirement. So here is the formula for that, and we will go into a little bit more detail about what all that means. And we have a negative exponent there. Our n is negative over I. So there's our formula. Okay? So example 3 gives you an idea of how all this works. Suppose a retiring couple wants to establish an annuity that will provide $2,000 at the end of each month for 20 years. So they want to be able to say, okay, how much money do I need to put in the bank right now so that I can pull out $2,000 a month at the end of each month for 20 years, and at the end of 20 years, all that money is gone. Okay? I don't want anything left over because I plan on dying at the end of 20 years. So if the annuity earns 6% interest, which we need to know that, compounded monthly, how much must the couple put in the account to establish the annuity? Okay. So what we want to do, we want to find the present value, the amount that we have to put in that will pay $2,000 at the end of each month for 20 years or 240 months. Okay, so our months are 240. Okay, and our interest is 6%, and that 6% is compounded monthly, so divided by 12. And so we have 0.06 divided by 12 equals 0.005. That's how much interest we're making per month. All right, so let's go ahead and write this. This is how much we're going to end up with, the A, or how much we're going to have to invest. This is how much we want. This is my interest, which I got from over here. 240 months, remember that's negative, over my interest. Okay? So, how you solve this? 1 plus 0.005, and then again you have that key that looks like this. So you're going to put in 1 plus 0.005. Oops, there's a minus sign right here, I'm sorry. And subtract that from 1, or I'm sorry, that to the negative 240 power, subtract that from 1, divide it by this, multiply it by that, and you end up with $279,161.54. So, if you want to have $2,000 a month for the next 20 years, you need to put in $279,161 into savings, and you will have enough money then for that period of time. Okay? So let's say that you just took $2,000, or let's just say, yeah, you took $2,000 a month for 20 years, for 12 months each year. You would have spent $480,000. Okay, so $2,000 times 12 months times 20 years would give you $480,000. How much did you invest? You invested that right there. So just in interest over that 20 years, you made $200,000. So it's a lot better to invest it at that 6% a year than to just take this money and say, I'll just take $2,000 a month for the next 20 years, because you will go through that a lot faster. You almost have double the amount by putting it in savings. Okay, so the rest of example 3 has to do with using your graphing calculator or using an Excel spreadsheet. And that brings us to example 4 in home mortgages, and we'll save that for the next video.